Sponsored by Panasonic. Smart factory solutions for any mix, any volume. Introducing the new NPM W2S, the ideal placement solution for manufacturers who value reduced setup and changeover time over volume.
Welcome to the Indium booth here at Productronica. Delighted to be joined by Brian Craig. Nice to see you again.
Good to see you again. How you doing?
Very good. Very
Super.
good. One of the things coming down the pipe, of course, is 5G. It's been talked about a lot. We're actually starting to see some applications coming out in Europe. And you're right at the heart of this with some solutions that help some of the challenges you get in 5G. Tell us a bit about it.
Right at the heart of it. We are the heartbeat in 5G. Now, when we hear the people in the public talking about 5G, we're all talking about streaming video faster and all that kind of stuff. That's interesting. But I think 5G is the beginning of another industrial revolution because we don't have the imagination yet to know the things that 5G is going to enable.
Right.
Because the communication speed from any device to another device somewhere else, maybe at the far end of the world, is super quick. So what that does is it facilitates us as human beings being able to do stuff that we can't do today. Now, the thing we know about would be we can be in a vehicle that's driving along somewhere, and that vehicle is knowing where everybody's cell phone is, where everybody's person is, what's happening to the street lamps, what's happening to the traffic lights, right. And it can plot its way safely through a busy city. 5G enables that, yep. To allow us to happen. And there are so many other applications in industry, like machines working their way together, machines being coordinated with what's happening in other parts of the world. Yeah. And the one that's most exciting, I think, of all is the connection with artificial intelligence, where we might be able to see a piece of equipment through some glasses and you're able to see the manual for that equipment and fix it right there and then in situ.
Okay.
I think that's cool.
Okay, I think that's certainly a cool application, and I've seen applications of that already on this show floor.
Yes.
Which are really cool. I'm not sure I'd call it artificial intelligence. I'd call it assisted, maybe.
Assisted intelligence. Maybe I misspoke.
Yeah.
But I'm so excited about all this industry, I don't know what to say. The words are fantastic.
I know. But so anyway, when it comes down to the interconnection for these materials, there's certain challenges. Can you explain a little bit about these?
Well, we've talked before about high reliability, and high reliability in things like 5G and cell towers, this little image that we have here with all these and transmitters and receivers and converters up here on the tower that we drive by and see them from the road. They're really hard to fix. You've got to be reliable. Right. And we know how annoyed we get when our cell phone loses a signal or something doesn't work for us in our modern world. And making that highly reliable is the key. And the part that we're most involved in is the attachment of the components to the substrates.
Right.
We make the joints that make these things happen.
Okay.
And one of the challenges with reliability is that if that component is not flat or begins to crack, then we have to repair it or it has to be replaced. Mm-hmm. And so the idea is let's make something that's not going to crack and not going to break down in the first place.
Right.
So we have this material that we call the inform. Mm-hmm. It's if you think of it with a preform, and within the preform, there's a matrix that supports that preform as it goes through the process. So an ordinary preform doesn't have that. Mm-hmm. When it melts or reflows, the die or the parts it's joining may not necessarily be flat. And when the joint isn't flat, it's prone to cracking. If it's prone to cracking, it's unreliable. If we can resolve that flatness issue, we reduce the cracking and we make the device more reliable. And by having this matrix inside the preform, then we have a reliable flat joint, low voids. Everything's going to reflow and last. Everything's going to last a lot longer without having any problems.
So it's like putting a little cage, if you like,
perfect
over the pad.
Perfect analogy. It's not so much over the pad; it's within the joint that we make. Okay. So you think of the cage. Mm-hmm. The solder will do what the solder does. It forms its joint between the two parts, mm-hmm. But where it flows to and how it flows is restricted by the cage, as you put it. Right. So that wetting is restricted. Mm-hmm. That slump or collapse of the joint is restricted, and you end up with the solder being exactly where you want it to be, but perfectly flat.
And the device perfectly planar.
perfectly. So that works really well. We've had a lot of interest in that, and it's beginning to be used in production now pretty much everywhere.
What is it called?
It's called the Inform.
Inform. Okay, there it is.
And magically,
one appeared.
it looks like this. So as you can see with the preform here, you have a little matrix, the cage is inside it, and that cage doesn't change, but the solder melts.
Right.
So the solder does what it does, the cage restricts where things are going.
Okay, well it's extremely small to see, but yes.
Yeah, it's
I believe.
We do small things, Trevor.
Okay. Yeah, I mean, this 5G revolution is amazing. I mean, the only thing I would say about it is that it has fairly short proximity. You need to have a lot of these boxes close to the area that you're transmitting to. Yeah. So that's expensive in itself, and there's going to be a lot of work involved in rolling that out.
Yeah. I think that's for sure. But you know, we're a material supplier, and we like to supply lots of materials. So the more boxes that are required, the better for us, of course. So we have to be efficient and help people to be reliable. The challenge between 3G, 4G, and 5G is, in addition to speed, the benefits that 5G offers, it doesn't go through buildings quite as well as some other frequencies. Yeah. And so you're right, you have to have these booster stations and additional infrastructure to allow that to happen. But in today's modern cities, there's lots of places to be able to do that, on top of street lamps and buildings and things like that.
But I think this is what's going to drive everybody to be living in the cities within 5 years, as they say.
Well, I don't believe that, actually, and I think you know, enabling 5G to talk to other network systems allows people in remote areas to have access to this wonderful world of high-speed internet as well. Right. So I don't think it really drives the cities, but you're right. A lot of infrastructure, a lot of parts, but hey, that's not a problem for us.
Exactly. Brian, amazing product. I'm very excited for you, and thanks for showing it to us today.
No problem. Very well.